Hello and welcome to the Introduction to ZEN Blue, Tutorial 2, Acquisition of a Z-Stack. My name is Dan Stevens and I'm an Application Specialist with Carl Zeiss Canada. Let's begin with our typical ZEN interface under the Acquisition tab. Before our tutorial, I loaded an existing multi-channel experiment. In order to add the Z-Stack parameters to my experiment, I need to activate Z-Stack by checking off the corresponding radio control box just below the primary imaging buttons. Having done that, I can see the Z-Stack controls available in the multidimensional acquisition column. Notice also that the Start Experiment button becomes active now, where before it was grayed out. The graphic above the Start Experiment button represents the type of image experiment that is currently configured, in this case a multicolor Z-Stack. Typical setup of a Z-Stack involves defining the range of the stack as well as the focus step size to be used when traveling through the stack. With those two parameters set, the number of focus steps is to be taken during the acquisition is determined, as it is equal to the total range divided by the step size. To set these parameters, it is typical to open a live image of your sample while visualizing the fluorophore that is best used to describe your range. Here I am imaging a brine shrimp. This is not a typical sample, but is one that shows very nice changes in the image while changing focal planes, so I've chosen it for the purposes of making it easier to follow what is going on when viewing this tutorial. Using the focus knob on the microscope, I'm going to move to one extreme of my sample focus range. I then set this to the first point in my Z-Stack by clicking the Set First button seen here. Once this is set, I move the opposite extreme of the Z-Stack and set this as the last point in the stack by clicking on the Set Last button here. The question you're most likely asking now is, does it matter what side of the Z-Stack is the top and what side is the bottom? The answer is no, it does not. However, for your own sanity, I do suggest setting the first and last in the same manner that the microscope acquires the Z-Stack. Regardless of how you set first and last, the microscope will always move the motorized Z components against gravity in order to achieve the most reproducible mechanical stepping. On an inverted microscope, that means the stack is acquired from the first image closest to the cover slip and the last image farthest from the cover slip, as you can see in this image. On an upright microscope, the first image is farthest from the cover slip and the last image is closest to the cover slip. You can remember what direction you are moving the focus by remembering thumbs in. That is to say, when you rotate the focus knob, if you push your thumb forward, you are moving deeper into your sample. This is true on both an inverted and an upright microscope. Alright, so now we have defined the range of our stack, we need to define the step size. This can be very simply done by pressing the Optimal button. The optimal step size has been calculated by the software based on the objective you are imaging with and the focal depth of that objective. The optimal step size is approximately half of the focal depth of the objective, and this value is a property determined by the magnification and numerical aperture of the objective. The impact of this step size and the theory behind it is worth discussion, but is beyond the scope of this tutorial. Now that we have the parameters set, let's begin the acquisition by pressing Start Experiment. Note that as we acquire, we can track the progress and position of our Z-Stack with the graphic in the Z-Stack window. The blue square shows the active plane of acquisition relative to the whole Z-Stack. With the stack acquired, we can navigate through the resulting data by moving the slider at the bottom of the image, or we can view a 3D representation of the stack if you have this capability available with your version of ZEN. So here we are at the end, our efforts rewarded with this nice little rendering of a portion of the brine shrimp. I reacquired this with the exposure time twice that I had in the video, and then deconvolved the image so that I could render it in 3D with a reasonable result. Because my screen capture software seems to compress the video significantly, I stepped out of ZEN for this slide and embedded the data directly. You may have noticed the images appeared pixelated in the tutorial at points. Look for future tutorials covering other basics of ZEN. You'll find these in the comments on my YouTube site, www.theperfectpsf.com. That's all for now. Good luck and happy imaging.